All right, I think it's time to start. For the last people who came in, there are still some seats scattered around, but it looks like almost everyone is seated, so I think it's time to start with my talk about robots, wizards, and goddamn infrastructure! Or, as you might have read in the program, how to be cool in the age of legacy. So today I'm going to take you through a quick journey about some interesting parts about RiksTV's transition from sort of like old-fashioned hosting to public cloud. First, a few words about myself. I'm what we call a fagsjef in Beck, which basically means that I'm a middle manager who still gets to program a bit. And I've been working with RiksTV as a consultant for a year and a half, and I'm a developer turned DevOps. And my background is definitely primarily from the developer part of the DevOps equation. I'm a Java developer originally. But luckily for me, like half the team I'm working in is from a more operations kind of background, which I think is kind of healthy because much of what I've been doing earlier in the DevOps space is developers trying to do both development and ops. And that is, if you've seen that, it's kind of cool, but not very pretty. So, first, I want to do a live demo. And I want to inform you that everything I'm going to do now is live in production on actually like quite heavily used production system. So if something goes bad and someone in the center back row screams and runs out, that's something we agreed to do. But it definitely means that something went super bad. Okay, so, wrong screen. Okay, we can fix that. Mirror, and there we are. Hello, Amazon. So, first, I want to show you something called EC2. How many here know what EC2 is? Okay, not everyone, probably more an Azure crowd than an AWS crowd. So EC2 is the elastic compute cloud part of AWS, which is basically where they run virtual machines. So you could say that EC2 is basically the cornerstone for everything in Amazon. Is where you do like the simple virtual machine thing. And I'm not going to talk too much about that. I'm just going to show you something real quick, and then we'll jump back to that later. So let's find something called auto. Where's my search? Auto. There we are. Auto scaling. So I click the auto scaling groups button here, and I search for something called play. So you can see that I find two auto-scaling groups here, and you probably don't know what that is, but that doesn't matter. So you choose one of them, and we can see currently it's scaled to, it's probably pretty hard to see. Let's zoom in a bit. Desired capacity 2, minimum 2, maximum 4. And I'm going to edit this, and I'm going to say desired capacity is now 3 for the Play API. So just like 2 words about what the Play API is. The Play API is basically our backend for playing things. So when RiksTV is, as you probably know, a TV distribution company. So whenever you play something, be that on your TV box or on the streaming platform on the web or whatever, we use the Play API. So if this goes down, then there's no TV for anyone until we run out screaming and fix it. So let's scale that up to 3. Save it. And we can see up here that there's an exclamation mark here on instances. So it says instances may be in the process of launching, hopefully, terminating, hopefully not. And something is going to start happening here. So we're going to jump over to Kibana. How many here have used Kibana before? About half. Okay. So Kibana is basically a log aggregation tool. So it takes log lines and lets you do pretty cool analysis on top of it. So what we're seeing here is the HTTP request log for the Play API. So you can see I've done request host filtering here. We just see all the requests going against playapi.rikstv.no. So currently there's about 250 requests per 30 seconds. So I'm going to add what's called a sub-bucket here and split the series on terms. You don't need to know what that is. And we're going to split it on hosts. So what we basically do then is that we see the number of HTTP requests coming in per server we have serving those requests. So as you can see, we have 3 servers, and as you might remember, the number was set to 2 as a side count. And that is actually because we have one canary node, because you can see the purple guy on top here gets a lot less traffic than 200. And that's because this guy, probably a little bit hard to see, but it says WPCA, and the C there in the server name stands for Canary. So it only gets about 5% of the traffic. And that's good, so we can do Canary deploy, so we can deploy new versions there and see, will it start failing in ways that we didn't with the previous version. So what you can see here is then, this is cumulative, so we can see the 250 requests split on 16 of them going to this server, 111 to this one, and 109 to this one. And we're going to get back to that later, but for now, let's talk a little bit more about RiksTV. Okay, so we're not going to have that on top of the presentation. Okay. So, RiksTV. I'm guessing probably a lot of you are Norwegians, and then I guess for almost all Norwegians, RiksTV is like, yeah, I know a little bit about that company, and it's old and weird, right? It's not like the most modern connotation you're going to get with a brand name. Because RiksTV is, or at least was, the antenna on the wall company. So what we did, like the whole business idea of RiksTV going back a few years, combines huge masts on top of mountains, which gives great coverage almost everywhere. I think there are 87 of those, the huge masts, and then it beam TV everywhere. So people use that in their houses, in their cabins, in their, what do you call it, campingvogn in Norwegian, or mobile homes in English, and even on boats. And it's been like a pretty good business for quite a few years. So this took over for the old like traditional broadcasting where you could get NRK and TV2. But then that started to be modernized. And the thing is, from the IT point of view, that is a fairly simple business model. You need a CRM system, so you need a customer relationship management system. You need to get hardware for your TV boxes. You need to provision to say that, okay, this guy gets access to this content, this girl gets access to this content. But it's all like, mostly you just combine things. You buy software here, you buy hardware there, and you plug it together with some integrations. And I'm guessing the people who did that 10 years ago or 5 years ago wouldn't agree that it was easy. But compared to what we're doing now, it's fairly easy from the IT side. It's mostly about sourcing and combining things, doing logistics and sales, and then you have a good business idea. Then enter this thing here. People started buying cell phones, which is good. I have a cell phone and I like it. And then these guys started doing things as well. So streaming very quickly became normalized or commoditized when YouTube appeared, because YouTube sort of changed the whole playing field as what people expected from a streaming platform. It should work all the time. And suddenly streaming, I remember, I think it was like 7 or 8 years ago, streaming was still weird. I'm not going to say porn, but porn. And then suddenly YouTube appeared and streaming became everything. Like I think I already streamed a YouTube video today, and I've like been here all day. So I don't know why that happened, but like you do streaming all the time. So your expectations to streaming platforms start to increase rapidly, and people don't distinguish that like, okay, YouTube, huge American company, RiksTV or Getto or whoever, like sort of smallish Norwegian companies with a whole different business model. You just expect everything to be as good as the best thing you use. So people expect RiksTV to have a streaming platform, and you expect it to be up all the time and to be great in the terms of feature set. And then suddenly this other thing started happening in the TV industry as well, which is suddenly everyone becomes a streaming provider. So we get Netflix, you get HBO, you get NRK, you get Viaplay. And I'm pretty sure you can get like 10 or 15 different streaming platforms with sort of different content, but also kind of the same content at the same time. And that obviously means that the market becomes super competitive. So time to market becomes really critical, and uptime becomes just like, it's not something you discuss, you just need 100% uptime. Now, obviously that doesn't exist, but for us, if we have that downtime, people change the channel on your TV, and suddenly like the sixth channel doesn't work on your TV box. And that doesn't fit inside people's head, like TV doesn't stop working. So that's sort of the reality we live in. So, and then we also recently launched a new streaming platform called Stream. It's the first like completely Norwegian pure streaming service. So it's super early yet, and it may or may not be a success, but it sort of shows the shift we've been going through from sales organization who could do 6 hours of downtime pretty easily 6 years ago to super competitive streaming provider now, basically trying to go, what did it say, heads to toe, heads to heads, trying to compete with the likes of Netflix. So if you haven't checked that out, you should definitely check out Stream at stream.no. You can get a 30-day free trial, so you should do that if you haven't. And that was enough of the advertisements today. So a little bit about IT in RiksTV. So again, most of you probably don't know RiksTV that well. So to me, it was a bit surprising to figure out that to realize that it's actually, from the IT side, a very interesting company. We do about 100 gigabits of second streaming, 100 gigabits per second streaming during peaks, which of course is a lot of data. We get about 200 or 300 requests per second against our backends during normal peaks. And then our traffic is also very, very peaky by nature, because specifically sports events drives a lot of traffic because people want to watch the Winter Olympics, you want to watch the World Cup finals, you want to watch the new episode of X on the Beach. So like these single things happening that everyone wants to watch. And so this is very interesting, like especially the Winter Olympics, the last time was in the daytime, right? So we'd think that drives traffic down, but it actually drove traffic up because people are watching at work. So that's good for us. We also have some legacy. We don't have like super legacy as I guess some here might be working with, but we definitely come from an old hosting model. We have some monolith-ish services, so that we don't have that like one super monolith, which is like everything evolves around this one. But we have a few services that definitely are way too big, and we have that feeling like we need to scale this, but we don't want to scale this 80% of it. We just need to scale this like small thing, but we can't because it's like stuck together with everything else. So we have that monolith feeling, and I'm pretty sure you probably wouldn't be here if you don't know that feeling. And we also have a quite interesting mix of in-house development and source services. So we combine sort of like bought platform services with commercial off-the-shelf software that we need to host ourselves, and quite a lot of in-house development. And we're not a very huge organization. We are 110 people in total, not including customer service. And about 40 of us are working with technology in some way. So that's either project management or developers or operations people or whatever. And also a fairly interesting thing about the RiksTV, it doesn't really fit too well into this presentation, but it's worth mentioning, is that we basically only do cross-functional teams. So there's no IT department. I think we have 12 or 13 teams in total, and we have developers in 7 of them. So that kind of it makes it interesting to try to make decisions in the IT space, because there's no centralized, there's no like one guy or one girl who makes every decision. It's just like you need to bring people together and try to figure things out. And before I move on, I also want to give a nod of the head to this guy, Trond, in the center back. He's the operations guy at RiksTV, who basically thought up much of what we're discussing here today. So we built it together, but Trond came up with a lot of it. So, and you'll be hanging out at the RiksTV stand today, right? Yeah, come say hi. Yeah, so if you want to say hi to Trond or talk about me and how great I am, you can find him at the RiksTV stand. Okay, so some goals for today. A lot of introduction here now, but we're going to get started. There's going to be technology. So what I want to show you today is that you can build a how you can build a horizontally scalable infrastructure for .NET without porting everything to .NET Core, which is like the super specific part of my talk. I want to walk you through what in general is required for horizontal scaling of infrastructure. And last and maybe not least, I want to show you that cool stuff on infrastructure is happening in Norway in reasonably sized companies. Because at least I've had the feeling that I go to conferences and I hear from people, and they're from Google and they're from Facebook, and they're doing like, okay, that's super awesome. And then I get back to work and I write Java. So like, yeah, it's cool that you're writing service meshes in Go, but I'm writing like Java for the enterprise. So I just want to show you that a lot of really cool things are definitely possible without being one of those huge tech companies. So a little bit about our team. I work in the site reliability engineering team at RiksTV. So moving from the whole sales organization thingy to the whole digital product development company, it was decided by Trond and some others that we needed to create a an SRE team. So SRE, for those of you who don't know, is Google's take on professionalized DevOps. So it's basically DevOps done properly. And for us, that has meant building a lot of infrastructure and tech, obviously, but also almost as much discussing and caring about culture, quality, and operational awareness. So basically helping the organization and helping developers know how to build scalable, robust, quality-centered applications with a lot of users, because it's partially a technology thing, but almost to as large a degree, it's a mindset thing and a cultural thing. And we've been working on that as well. And we've also been working quite a lot on developer experience. So our team has been working for about 1.5 years, and we've been on and off 4 people. It's been a bit like some people coming, some going, but I would say on average, we're 4 people, and I think we're looking at being maybe closer to 3 in the long run. Just to give you sort of a feeling about what we're talking about. We're not a 20 people team, but it's not like left-hand work for 2 developers either. So what we've been doing mostly is migrating from our old platform, which I think it's fair to say was pretty much becoming a burning platform. As I mentioned briefly earlier, we had outages for hours because just like the platform went down, period. So there was a lot of migration work involved, and we did a lot of work around that. And I think like the triggering point was it the Winter Olympics, John? When you ordered the server from the other hosting company? Anyways, it doesn't matter. There was a huge sporting event coming up, and we were feeling like, yeah, we're probably not going to be able to scale for that. So we need new servers. And I think the lead time for those servers we needed was 4 weeks. And I mean, that's not super good when you need to scale. Like a manual, like almost ordering by fax machine process to get new servers, it doesn't quite feel right. So we needed something really quickly that could scale completely differently. And we needed something like with less inherent downtime than we were having, because things just went down occasionally, and it shouldn't. So we set up, or at least I've reversed engineered a list of requirements we had. We wanted service isolation, so we wanted to be able to let service A crash without bringing down B, C, D, and E, which we definitely also tried a couple of times. We wanted to avoid too strong platform tie-ins. So we want to be able to replace our configuration management system without replacing our deployment platform, or we wanted to be able to replace our virtual machine provider without replacing our password storing or password and secret system, and so on. We need to be able to handle boundary-based security and messaging-driven architecture because we use those. We wanted something like immutable infrastructure, basically meaning that we don't want to keep servers around for a long time, because we tried that. And I'm guessing a lot of you have probably worked with these old servers, like, yeah, you had 7 years of uptime, which is cool, but it's also crap. Because they become snowflakes, and we have snowflake servers. Like servers that have been around for super long, and you patch them manually. And you never know what's going to happen when you use a snowflake server. So we don't want that anymore. And we also wanted quick horizontal scaling, as I talked about. That was like probably the main driver. And we also needed interoperability with our existing hosting provider. So we needed to be able to move stuff gradually, and we needed to be able to talk together while we were moving it. So the obvious choice for what we're doing, to me, is basically this: Kubernetes, or some other kind of container orchestration platform. We use Kubernetes for a lot of stuff, and that's great. It's awesome, and you should. But the thing is, we mostly couldn't, because our problem was .NET Classic, or like old-fashioned .NET applications, which basically aren't completely container-ready. There are things happening in that space, and if you have the time, you should at least look into that before consider doing what we've done. But for us, it wasn't ready enough, and it wasn't mature enough when we needed it. Because we needed to migrate now, and then we decided to roll our own. Which sounds like a bad thing, but basically what we did was figuring out how do we want to run applications on servers in the cloud without like letting DevOps be clicking around in the Azure UI or the Google UI, but actually having something that could be done automatically and be super awesome. Okay, how are we doing so far? We good? Yes. 3 thumbs. That's good. Okay, back to the demo. So, no, you're still not seeing this. Okay, here we are. So, you probably remember this graph. If not, I'm a bit disappointed. So first, let's jump to EC2 and see how things are looking here. Hopefully, something should be happening around here. And we refresh it. And okay, so we're seeing 3. That's good. So let's move over to Kibana. You can see we tried to scale out at about 10:23. So that's about 17 minutes ago, because now it's 10:40. And if I refresh, boom. So you can see that around 10:38, a new guy appeared. And it looks like that's WPM 0501, so on and so on. So that's actually what it takes to scale out now. And if you keep in mind that I said that like the last time we needed to do this, or like the triggering time we needed to do this, it took 4 weeks. And this took 11 minutes. So it's definitely a difference. And I'm guessing some of you are thinking, if you can do this, then why are you sitting here, or at least standing here, like pointing, clicking, doing this manually? Why isn't this done automatically? So this is something we introduced quite recently, and there's a service in AWS called auto-scaling. AWS auto-scaling, which is not to be confused with what I just went into, which is EC2 auto-scaling groups. AWS auto-scaling, different thing, obviously. So let's go there. So we have these supremely nicely named scaling plans, and I think it's this one. And I think it's, yes, this one. So what you're seeing here is a auto-scaling group. We based our forecasting on CPU utilization, because that's the the bottleneck for this particular system. So what you're seeing here, is it easy enough to see for you in the back? Yes, nodding. No thumbs, but nodding. That's good enough. So you can see here that we're measuring the CPU load. So the blue line here is the actual load, while the yellow load is the forecast. You can see we're about here now, and this has been our last week. So Amazon expects our next day to be like this. That's the load forecast. So based on that, Amazon also does planning does instant count planning for us. So we automatically scale up and down throughout the day. And you can see we mostly stay at about the same scaling. So we are basically running 2 servers all the time, because we set our lower limit to 2 because we want the redundancy. We can also see that Amazon automatically scales up for like planned peaks, because we know that people generally tend to watch more TV at 8 in the evening than they do at 4 a.m. in the morning, for example, which I think is pretty cool. And we're definitely going to do more with this in the future. But I think, to me, pretty awesome. Okay, water time. I'm going to try to take the mic away, because the whole presenter drinking sound is not a good one. Glub, glub, glub. Thank you. Okay, so I cough into the microphone instead. That helps. Okay, so how do you go about making a horizontally scalable infrastructure? There's a great guide for that on the internet, of course, which is called the 12-factor app. The 12-factor app describes sort of like the general guidelines for how you create a modern cloud application or cloud service. And it's great, but at least to me, it contains too many hard words. So it sort of doesn't really fit inside my head. So rather than doing that, I have created my own, which is not on the internet, it's on my slide. And it's the making a horizontally scalable infrastructure for dummies guide. So number 1, you're going to need somewhere to run your servers. Number 2, you're going to need to provision your servers. Number 3-ish, you need to build and store artifacts, so deployments. And I'm not going to talk anymore about that. It's because in this context, I'd say it's easy. And I know there are people who have like their full-time job is doing continuous integration setup and servers and so on. And it is hard doing it. It's just like it's a fairly simple problem if you abstract it. It's just, okay, you need to build artifacts based on source code, and then you get a zip file or a DLL or a jar file or whatever, and you just store it somewhere, you can access it later. That's easy. And of course, the details of it can be super hard. But so that's why I'm not going to talk about it today, because we're just going to assume you have that zip file somewhere. You need to be able to make deployments. You need to be able to route stuff to your servers. And in order to route stuff to your servers, you're going to need to know where stuff is running. So that's basically what you need in order to be able to automatically create new servers, deploy stuff to them, and route in traffic. So we do this using these 5 guys. And I will definitely leave out a lot of details here, because there are a lot of details. But I think I'm going to show you enough that you get a pretty good overall understanding of how this is done. So it's also nice to know that everything we're talking about, or I'm talking about here, is fully automated. It's in version control. We don't click around in the UI. Like the clicking around in the UI I did earlier, that's basically what we do. We also use a lot of CloudFormation, which is basically Amazon's Terraform option. And I'm also not going to talk a lot about that, because it's hard to do without it becoming super detailed. I know Torstein back here gave a talk about Terraform on Azure yesterday. And I'm guessing there are, like, if you want to find the resources on this, there are a lot of them around, but I'm not one of them. So let's move to dummy guide item number 1, which is you need somewhere to run servers. Okay, so now it's going to get technical, so I need to show my guns. Okay, so where can we get servers? You probably kind of expect this from the demo now. We use Amazon EC2 or Elastic Compute Cloud. It's basically a platform for running virtual machines, which is great, and it's basically just what we need. So this, I don't expect you to be able to watch this video, and I don't want you to, so I shouldn't have it in there, but I do. So this is basically what you do in the UI in Amazon to run virtual machines. You just click around and you choose server sizes and you choose what kind of OS you want and whatever. And then Amazon bring them up for you. Oh, and I'm just going to mention a few of, because we are mostly a .NET shop, so a lot of you would probably be expecting us to use Azure, but we're not. We're using Amazon. No explanation provided. No, it's actually, we did a review and we started out on Azure, and Azure is great. But like for our specification and our preferences, it just turned out AWS is actually a better choice. So, but I'm not going to say what would be better for you, but we went for Amazon. So that's sort of like the solution to problem number 1. We need servers, and now we have servers. But where does that take us? There is no auto-scaling in me clicking and pointing around and getting up a generic Windows 2018 machine. That doesn't give us horizontal scalable infrastructure structure. So what's next? Okay, so we're still on, you need someone to run servers, and you're going to need to like have your own servers, not just Amazon's generic Windows thingies. So we use something called custom AMIs or AMIs. AMIs is Amazon's image service, which is where we build and install our own specific RiksTV Windows machine builds, which is Windows with a little something extra. We install .NET, we install the Datadog client, which we use for monitoring, and a lot of other stuff that we know we need this for all our servers. So okay, it's getting kind of better. We now have machines we can bring up, and these are going to have installed things that we generally like on our machines. But that doesn't help us, because we don't want to do that manually. We don't want to sit around scaling up machines or like bringing up new machines, taking them down ourselves. So then enter Amazon EC2 auto-scaling groups, which is basically a service that bunches servers together. It lets you describe a type of server or kind of server, and then you can just say to Amazon, yeah, I'm going to want 3 of those. So you just do that for me. So, and it could also, as the name implies, be set to automatically scale up and down using other services. Obviously, the name auto-scaling groups gives that away. So we're getting there, because now we're going to be able to add machines, and we can remove them again. So we now have generic machines that we can bring up and down, or generic RiksTV machines, which you can bring up and down automatically. But that still doesn't help us, because the machine, once it comes up, is going to be completely useless, because it's just going to be generic, and we can't tell like deployment number 1 from service B or message handler C. So what do we do with those? Okay, so enter something called user data. in Amazon. And I'm guessing like every virtual machine provider platform is going to have something like that. User data is basically what Amazon runs every time we bring up a new machine. So once the machine is up, you have like all this game go, no, sorry, user data go like, yeah, I'm here, I'm a new machine. What are you going to do with that? So now we come to problem number 2. We're going to need to provision our servers. So provisioning is, to me, like one of those weasel words in infrastructure, because I always have the feeling like I should know what provisioning is. Preparing for this talk, I actually tried to Google it to make sure I actually know. I Googled it, and I like read the first 4 hits, and I'm still not sure what it means. So if you're feeling I don't know what it means, or you personally feel that you don't know what it means, it basically means just to configure a new machine to be like specific and ready to use. So we use something called Ansible for this. How many of you have tried Ansible or know about it or whatever? Okay, a few. No, definitely not all. So Ansible basically lets you configure servers. It's a tool where you write a lot of configuration in YAML, and then you can take that YAML file and point it towards the server. I'm going to show you what it looks like in a few seconds. So our issue here, because you could definitely do everything we're doing in Ansible in user data. But as I showed you, like the user data box is this big. That's not a cool place to write 80,000 lines of provisioning code. So you don't want to do that. So, and also to set up like a completely fully working Windows machine, you need to restart a couple of times, and you're gonna need a lot of configuration, and you don't want to like actually launch a new server doing 20 minutes of provisioning just change. Like, does that change I did in line number 70,439 work? You want to be able to test that individually and isolate it and so on. So that's why we use Ansible for that. So again, don't worry if you can't really see the video. This is what Ansible configuration looks like. It's YAML based, and you have like a lot of plugins. So you have a lot of like readily made ways to do this and do that. So if you want to install the Datadog client, for example, there's already going to be a module for that. And there are modules for a lot of things, but you can also quite easily create your own modules. So what you can't see me doing here is running our Ansible configuration against a specific server from the command line. But then the next problem in doing this automatically is you don't want to sit around. I don't want to sit around in 4 in the morning. Okay, in case we need to scale up now, I should be able to run this Ansible playbook script. I definitely don't want that. So we, or at least originally Trond, wrote something called AnsibleJobService, which is basically a web application for doing the exact same thing as I did from the command line in the previous video. So you can see here that you may or may not be able to see that I'm running a file called site.yaml against a specific server, which is basically the exact same thing as I did from the command line. Okay, so then we're getting nearer. That's a cool word. Okay, so a new machine comes up. The user data script gets run, and then what you may or may not be able to see here is that it says, invoke RiksTV self-configuration, allow reboot verbose. So what that is a PowerShell module we've written, which basically notifies the AnsibleJobService that a new machine has come up, and I'm ready to be configured. So you should run Ansible provisioning, so server configuration against me. So that call goes out, and then AnsibleJobService starts a job against that particular server. And then we can actually see that in our own UI, that the target identifier is the new machine, and the job source is something called self-configuration. So you can see in the UI that this is not something that Jøran triggered using the UI. It's something that was automatically triggered by the infrastructure from a new server coming up. So we're getting one step closer. We then have a fully configured EC2 instance with meaningful stuff running on it. But still, we're going to want applications on it. So that brings us to dummy guide step number 3. You need to be able to make deployments. Bless you. So I'm guessing on a .NET conference, this probably is like, yeah, obviously he's going to say Octopus Deploy. Coming from a Java background, this is like the most amazing piece of technology I've ever seen. Because like for my entire life, deploying things, that was like command line running weird shell scripts. It works. But like the first time I saw Octopus Deploy, it's like, dude, you just click to deploy? And you can set up rules so like only your product manager can deploy to production while you can deploy to UAT. I'm pretty sure this exists somewhere in the Java sphere, but I never used it and I never saw that. So I think Octopus Deploy is great, and it's also shit. And we're going to talk a little bit about that. So in case you haven't used Octopus Deploy, it basically looks like this. You click around, you deploy. I could cancel, I don't want to do that. And what you're seeing here is the great part about Octopus Deploy. It's like, it's super easy to use, it's easy to understand. It makes deployments a joy. But what you're seeing here is also the shit part about Octopus. Because our major problem with Octopus is configuration. I think we have like 150 different deployments, and we're creating all that config in the UI. So that the description of how you create a new service or a new deployment is basically find an old one that you like, copy it, adjust the things you need to adjust, and you have a new one. So imagine doing that for 2 or 3 years. So we're gonna have like a devolving tree, or like some improved deploys, some worse deploys, depending on who made them, and they're pretty much all unique. And that's not a good place to be. So like in general, Octopus is good, but I think if someone were to, for some reason, invite me and talk about this in a year and a half, I'm pretty sure Octopus won't be there in this presentation unless they fix this, because it doesn't work for us at all, the whole configuration thingy. So Octopus Deploy basically works like this. You have the Octopus server on your left hand, my right, and you have something called Calamari installed on each server. So the Calamari Calamari are actually small octopuses, so it's very appropriate. You have small octopuses on each server you're going to deploy to. The Calamaris connect to the Octopus Deploy server, and this way the Octopus Deploy server knows where it can deploy applications. So in our context, that means that, of course, as part of the server provisioning, we install and configure Calamari on each servers. The Calamari then report back to Octopus Deploy, which becomes super happy because it now has EA, a new deploy target. And then we use something called deploy triggers for new servers. So what you can see here is that we do automatically deploy when a machine is enabled and found to be healthy in any environment for the role. And here it says the service is external AWS Play API or API Play. So what we're saying in Octopus Deploy is that once a Calamari reports in and it's a new server and the server looks kind of healthy, deploy to it. And then we're getting somewhere with auto deploys, right? So when a new Calamari reports in, Octopus Deploy deploys, and that obviously makes it very happy. So the next problem is, once we have new deployments, how do we know how to route traffic there? Okay. Everybody still following? Yeah? Mental thumbs. Yes, actual thumb. Physical thumb. That's good. Okay, it's not going to get harder from here. We are more than halfway through, and it's going to get a little bit more complicated, but maybe easier. Something like complex and what is talk? Simple made easy. Yeah, if that doesn't make sense, go home and Google simple made easy and watch the presentation you find. It's going to blow your minds. It blew mine at least, but it's not a feat. Okay, so step number 5. You're going to need to route stuff to your servers. For this, we use something called Traefik. Now, Traefik is a load balancer, and I'm pretty sure all of you have worked with load balancers knowingly or unknowingly. Some familiar names in the space are Nginx, Apache, BigIP, and a lot of other ones. So Traefik's second superpower, besides having an awesomely cute logo, is that it's highly configurable and made from the bottom up to be very dynamic. So a lot of load balancers are pretty old because it's hard technology to write because it needs to work every single time. And that means that they're based on the old regime where you yeah, you know that you have these 4 servers. You can just like punch the IPs directly into a UI or an XML config file or whatever. While Traefik is a neural load balancer, and it's built around like the whole assumption that servers or services are gonna be ethereal or like coming and going automatically. So configurations need to be as well. So it's all about like just tying in different providers for configuration and so on. So the Traefik UI looks like this. It basically maps what they call front ends to back ends. So you have a front end definition, which is you're going to have a server here that looks like this, and it's going to behave kind of like this. And this is where you find the back end. And as you can see, the UI is, or probably not so easy to see, but it's completely static. It's a read-only UI because the config is meant to be just elsewhere. So Traefik is super good at routing traffic, which the name kind of implies. So you can route based on on host name, paths, whatever. It's good at doing things like the canary node, which I showed you earlier in the demo. So you can say that like, I want this node to have this much traffic and these nodes to have that much traffic and so on. But still, it's going to need to know about the new server because even though it's like good at routing, it's not good at magically knowing about the appearing servers. So that brings us to our last problem on the demo list, which is you need to be able to know where stuff is running. And for this, we use something called Consul. Now, Consul is a service, and a lot of people have probably heard about it. To me, Consul is a magic DevOps word, or at least it used to be before I started using it myself. If you go to their website, I think they describe themselves as a service discovery mesh and distributed key value store. So it's like, yes, buzzwords, this is gonna look awesome on my resume, and it does. So for us, it's primarily a tool which is remarkably good at keeping track of services, servers, and like what runs on what. I was also gonna mention, we also use it for configuration. So that's the key value store part. But I leave that out of this presentation because that is also a fairly simple problem. So Consul mostly looks like this. You can see here we have the services external API prod main play API, and it points down to, well, I point down to it running on the nodes, WPCA and so on, WPM, WPM. So these are basically the same nodes that I showed you in Kibana and that I showed you in EC2 earlier. So Consul keeps track of where these are running, and it even has this nice little feature where it checks whether or not a service looks healthy on a particular server. So it has like first citizen built-in health checking, which you can do using HTTP checks, or you can run local scripts, and it supports a lot of different ways to check whether something looks healthy or not. So the way Consul mostly looks is like this. So it kind of looks like the whole deployment model for Octopus Deploy, that you have a centralized server called the Consul master. It's a bit simplified here because in practice it's a bit more complex than that, but overall it's like this. So we have the Consul master, you have agents running on each EC2 instance. These agents do whatever health checking is needed against the Play API, and then reports into the Consul master, which keeps track of it across environments and across data centers and so on. So in our context, in our overall picture, and I'm guessing you're starting to anticipate what it's like. We have AnsibleJobService, which during provisioning installs the Consul client on each server. The Consul client then, actually that is done, we actually notify the Consul client that a service is running on a given server during Octopus Deploy. So the Consul agent then knows, okay, the Play API is running on this server, so I'm going to health check that in this way, and once it's running and it's healthy, it reports that into the Consul master, which then knows about the new deployment. So with Traefik, a new server then appears, fully deployed from Octopus Deploy. The Consul agent then reports into the Consul master, hello, we have a new deployment running on a new server. Traefik then subscribes to updated configuration from Consul. When a new request comes in, Traefik knows, yes, I can find that on that new server, and boom, that's it. We now basically have horizontally scaled that automatically and can route traffic to a new server. Okay. So if you're feeling a little bit like me right now, it's a lot to take in. there's a lot of things to fit into your head at one time. But if you sort of reel back, nothing of what I told you now is actually hard. I'm pretty sure most of you understood at least 5 of the 6 steps, maybe even all of them. It's just like once you try to tie everything together, it becomes a little bit messy because there are so many different concepts and so many different technologies, but none of them are actually hard once you isolate the problem. So what we're doing, we use Amazon EC2 for virtual machines and scaling. We use Ansible for machine provisioning and configuration. We use Octopus Deploy for deployments. We use Traefik for reverse proxying and load balancing. And we use Consul for service discovery and configuration. So if I try to summarize all of this into one like mother ugly auto-updating PowerPoint slide, this is what's going on. So we have an existing setup with 2 servers, Traefik happily routing traffic to those. And then the auto-scaling groups in the bottom there triggers, and it says, OK, we're going to bring up a new EC2 machine based on a given AMI. Then user data on that particular server reports into AnsibleJobService. AnsibleJobService starts a provisioning job against that particular server, which installs the Consul agent and the Calamari, which is the Octopus Deploy agent. So the Calamari then reports into Octopus Deploy. Octopus Deploy deploys the application it wants to that particular server. The Consul agent then health checks that new deployment and reports into the Consul master. Traefik then subscribes to configuration changes in Consul and knows about the new server and is able to route traffic there. And that is actually everything. So to try to like tie this all together, I would say this is pretty awesome. I think it's like a super cool, complete setup. But you should use containers and you should use something like Kubernetes if you can. Because, of course, this is a lot to build, and Kubernetes basically does this. But the good thing is, and I'm guessing the reason why there actually are quite a lot of people here, is that not everyone started from scratch 2 weeks ago. Most of us have we have applications we wrote 8 years ago and 12 years ago, and some of them are going to be hard to fit into a container in the near future. So the good thing is for you, if you need to do this, this is something that can be introduced gradually. We didn't, and you don't have to build this as like, OK, we're going to build this platform now, and we're going to spend half a year doing that, and then we can start like moving the first services. We built like the bare minimum we had to, and we also like plugged in a lot of the new stuff to the old infrastructure, which made it easier to shift stuff over as we went along. So we've been improving that platform a lot since we moved the first service. And it's adaptable to any service that runs on Windows, so it doesn't only fit for web applications, and it doesn't only fit for in-house developed applications. And the design also supports services that can't scale dynamically, and we do that. So we actually run, I think, episode of it on a similar setup. Our particular episode setup can't scale this way, so we can't just like write 4 in a UI and then we're going to get 2 new servers. We actually need to do that manually because there's a lot of like manual plumbing that we weren't able to automate. But it's super nice that it fits into the same kind of setup, and you can use the same automation, and you can use the same reproducibility of server configuration and so on. So the takeaways you should bring home with you today is we did not build all of this in one day. So if you think like, yeah, this kind of fits into my world, you should use this as a roadmap or an inspiration, but not like something that you need in order to start doing everything else. So take the bits you need. As I said in our requirements list, we designed this to be pluggable, so we can replace a lot of this without it impacting anything else. So if you like, yes, this sounds like good to me, this sounds like a good idea to me, this sounds horrible, then drop the horrible part, whichever one that was. And you should like always keep on improving one thing at a time, and that should also be your approach to this if you want to do it. That you should start with, okay, which part of what I talked about today is actually a problem you have now, which you need to solve now. And you might maybe you can start doing service discovery using Consul, and maybe that's a nice place to start for you, and then you can gradually move on from there. Because the thing is that if you do this a step at a time, and you start doing small improvements on where you are today, then I think I'm pretty sure that all of you can do this, and that means that you can be cool in the age of legacy. So that's about it. I'm going to be here for quite a few more hours. I'm going to be hanging out at both the Beck stand and the RiksTV stand most of the day. So if some of you feel like, yes, this is awesome for me, but that guy was on a bullshitting because there's no detail about how he did it here, then you should go find me, Trond or Stian, or like people hanging at the Beck or RiksTV stands are probably going to be interested in talking about this. So thank you for coming, and I hope you enjoyed it.